Okay, so for this first problem, it asks for the mass, and we can see that this has more particles than this one does. So the answer should be B is greater than A, and the reasoning, I won't write it down, but you can write it down. The reasoning is that B has more particles than A. All right, volume. If we look at these two, if we measured it with a ruler, length, width, and height, this takes up more space. So B is greater than A because B takes up more space than A. The box is just bigger. So the box for B is bigger than the box for A. For density, if we look at the distribution of the atoms, we see 4, 4, 5, 5, 4, 4. If we took the same amount of space, if I drew a line like this, we could say for the same unit volume, we have the same number of particles. So it turns out that the density for A and B are equal because the distribution of the particles is the same per unit volume. Even though this has more mass and more volume, the density is the same. Somebody else talked about it as compact. These are just as compact as these are. Okay, down here, same idea. Mass has to do with the number of particles. So A and B, B has more particles than A. And between A and C, C has more particles than A. So that's the reasoning, is the number of particles. Volume, B is a bigger box than A. And C and A are the same volume. And for density, A and B are the same density. They are equally compact. But for C, C is a bigger density than A because the particles are closer together than A. There are more particles per unit volume. These have the same unit volume, but there's more particles in C than in A. So those are your reasonings. Make sure that you have all your reasonings written in for tomorrow. Okay, number 3. It says that assume the particles are uniformly distributed throughout. The particles with larger size have larger mass. So which is more dense? Well, we're assuming that these particles have more mass, but they take up the same amount of space as particles in F. I know that the particles themselves are bigger, but you want to look at the size of the box for volume. So here, E is more massive, but they have the same volume. So we have more mass per volume in E. So E is more dense, and our reasoning is it has more mass for the same amount of volume. Okay, this grid was not very well printed out on your worksheet, so make sure you have kind of the grid down. But this one we're talking about slope. Oh no, excuse me, A. You have built a two-pan balance, and you compare the masses of substance A and B. What would happen to the balance if you put equal masses of A and B? If you had equal masses, they would balance. What if you had equal volumes of A and B? Well, A is more dense than B, so if they had the same amount of volumes, just like on up here, or just like here, they have the same amount of volume, they should have more mass. So if we have the same amount of volume, substance A should make this go lower because it has more mass for the same unit volume. And make sure you have your reasoning explained here. B says find the slope of each. So I like to pick two convenient points, and if 0, 0 is a possible point, I'll always pick it. And here I can see this is a nice cross for my line for substance A. And here, this is a nice cross for substance B. So for A, my rise over run is equal to, well, my rise from 0 is from 0 to 80, so that's 80 divided by my run, which is 0 to 50. So when I put this in my calculator, 80 divided by 50 equals 1.6. So it is 1.6. This was grams and milliliter, so grams per milliliter. And this is the density. Oh, and write a for every statement. So for every 1 milliliter, there are 1.6 grams. Okay? So that's A. And B, my rise is from 0 to 30, and that's grams. And my run is from 0 to 60, 60 grams, milliliters, excuse me. So this is 0.5 grams per milliliter. And my for every statement is, and you'll write this out, for every 1 milliliter, there is 0.5 grams. Okay? So then these just all require for every statements. So for C, it says if you put 10 milliliters of A on the balance pan, what mass of B would you need to make it balance? Well, that means the mass of A needs to equal the mass of A needs to equal the mass of B. So I need to figure out the mass of 10 milliliters. So for every 1 milliliter of A we have, well, from up here, my density, for every 1 milliliter, we have 1.6 grams. So if I do the same for every statement for 10 milliliters, for every 10 we have, well, this is 10 times larger, so this needs to be 10 times larger. We have 16 grams. So on my balance, if I have 16 grams of A, what do I need to balance out the same, what do I need for B for there to be the same, for there to be balanced? I also need 16 grams of B, and then I have a balanced. Okay, 35, if you have 35 milliliters of B in one balance, what volume do we need for A in order for them to balance? Well, in order for us to get something balanced, we need the same masses. So the first thing we need to do is figure out the mass of B. From our density up here, for every 1 milliliter, right, we have 0.5 grams. So for every 35 milliliters we have, well, this is a smaller number than 1 milliliter, and it's half as small. So half as small of 35 is 35 divided by 2 equals 17.5. 17.5 grams. That's half as big. So on our balance, we have, right, on our balance, we have 17.5 grams of B, and we need 17.5 grams of A. But the question is asking what volume of A we need. So we need one last for every statement. This is talking about B. So my for every statement for A would be if for every blank milliliters of A, that's what we're trying to find out, we have 17.5 grams of A. Well, my for every statement for A is for every 1 milliliter we have 1.6 grams. So how are we going to get this? Well, this is 1.6 grams smaller. It's 1.6 smaller, this is 1.6 bigger. So if I want this to be 1.6 smaller, then I take my 17.5 and I divided it by 1.6. And this will give me about 10.9. So my volume will be about 10.9. That's what my volume will be of A. So that one's like a 3-step problem. You had to know the density of B, then you had to do for every 35 milliliters. That gave you the mass of B. It's going to be, what's the volume of A would you need to, in the other pan to make a balance? So we have the same mass. We need the same mass for A. And then we had to work backwards to use the density of A to figure out how many milliliters of A. Okay, and the last one, the density for water is 1.1. Well, actually, I'll finish this one on the next video.